Here we are again, second part of statistics. Okay, well, welcome back. Dr. Zest, Anthony Dallmann-Jones here, and talking to you about statistics simplified. All right, so let's start with a problem. We're going to do the problem a little bit later, but let's just talk about the way the problem is written. Okay, so here's what you see. Confusing things. Okay, we have a group of scores. Let's figure the average, the sum of squares, and the variance and the standard deviation. What's missing? A really important word is missing. Let's look at it again. We have a group of scores. Let's figure the average, the sum of squares, the variance, and the standard deviation. Get busy. You can't do it yet. Not accurately anyway. Oh, you could, but if you're guessing, we don't want to guess in statistics anymore, and we have to. So what word is missing? Did you figure it out yet? I'll say it one more time. We have a group of scores. Let's figure the average, the sum of squares, the variance, and the standard deviation. Yes. The word sample or population is missing. Okay? That's what's missing in the statement. Okay? And without it, you cannot proceed. Okay? If it is a population score or a sample score, let's just say it's a total set of scores from a population. Or it could be a set of scores from a sample. Okay? But we need to know which because it's going to change our formula. Just a little bit of refreshment on that is that when we do, where is it? Here we go. When we do our calculations and we're dealing with a sample, we're going to be subtracting right there. We're going to be subtracting 1 from the number before we divide into the sum of squares. If we're dealing with a population, hope I said that right, population, we're just going to divide by n. If it's a sample, we're going to be dividing by, boy, this is all reversed for me. I'm so crazy here. There, yeah, n minus 1. Whew. See if this was set the right way so it'd be easy for me. All the stuff would be backwards. Yeah, so it'd be real easy for me to do, but it'd be hard for you to see. So that's the wonderful world of making films. Okay. All right. So that's why we need to know that. Also, our symbolism is going to be a little different. If we're doing a population, we're going to see a big X instead of little x's representing scores. We're going to see the mu symbol representing mean or average instead of a big M. And we're going to see the little s for variance and instead of the Greek symbol that's over there, squared. And the same way with our standard deviation is going to be the square root. And it's either going to be the symbol if it's in a population or it's going to be a little s if it's in a sample. We're going to see a large n if we're talking about a number in a population, a small n if we're talking about sample stats. Okay? So does that make sense? It's just really important to differentiate between population statistics and sample statistics. So, because it'll throw off your figures. And what we're trying to do is be as accurate as possible because we're talking about a false world of a handful of people, and we're talking about the average or mean and the variation or the deviation away from, or we're talking about the deviation away from the mean and the variation in terms of how people, how their scores are differentiated from one another, separated, congealed together. In other words, their variance, how far apart they are from each other. And that gets to be important because, again, you're trying to be accurate. And so if you had, let's just say you were doing spelling scores, and we're going to do an example of one here in a minute. We're going to do spelling scores, and you're going to say the average spelling score in the room was 7. Okay, so you go, okay, most people probably just got like a 7. What if you found out that there were 3 people that got 14 and 3 people got 0? Okay, nobody got a 7 or even close to it. But quote, the average would be 7 because you have these extremes. So you can see, you can get the average or the mean, but you can't tell how the scores were distributed. And it would be to walk in and say, oh, this class is an average class, they all have 7, and you start teaching to them as if they all have 7, you're going to have a group of people who are advanced beyond 7 capability, and you have a group of people who don't get it at all, you know. And this happens in a lot of classrooms and families and business meetings and organizations, you name it, where you try to teach to the middle of the room, we call it. And the middle of the room may not be there, okay? When we talk about standard deviations, we're talking about how far away from the mean, from the average, scores are, okay? We're assuming that on that, quote, an average population, and if a sample is average representational, a representative of that population, they'll all be mostly in the middle around the average, you know? They say that there'll be 95% of the people within 2 stanines, 2 standard deviations to the right and the left of the mean. And then out there in the tails of that bell curve, you know, there'll be like 5% on either side. So I hope that makes some sense to you too. So maybe we've got a good description of how this whole thing works. We've understood some terminology, some symbolism. We see what we're trying to do. We're trying to describe how people are doing on whatever, on love scores, math scores, spelling scores, waist sizes, how many like Cherry Garcia ice cream as opposed to strawberry shortcake ice cream, etc., etc., etc. And we're trying to get a quick glimpse, almost like a meat thermometer, a quick reading of as accurate as possible of how this group, population, or sample is representing itself by its scores. Because I'll make one more example, then we'll stop this second part. We'll go to the third part. Let's say you have 700 people who all got a score on something. So you say, well, how did they do? You could say, well, person number 700 got an 89. Person 699 got an 86. Person number, you get the idea? You go through all 700 people, get out, and person number 3 got a 6, and person number 2 got a 6, and person number 1 got a 3. That's how they did. So you'd have to read all 700 scores. And so this other person is sitting there paying perfect attention, going, yeah, okay, I get it. There's an 89, and there's 2 88s, and there's 187, and there's 16 85s, and so forth. I get it. They'd be asleep, or they would have shot you, or left town, or something like that. So we're trying to get it down to shorthand, you know what I'm saying? So we can grasp an understanding of something in a quick way, because time is money and money is time. But if it's not done properly, of course, statistics can mislead us. So we're trying to prevent that from happening by understanding, grasping what's really going on with a group of whatever, scores, people, tests, tastes, etc. Okay, that's the end of part 2. And we'll go to part 3, where we're going to work a problem together. And I think this will make things crystal clear. So in 3 parts, we will have covered the whole backbone of statistics. And if you're more lost at the end, I'm going to be so sad, because I really thought I was making things better. Also, you can, I will send you these crib sheets that I've made up. And I'll be glad to give you a copy, a PDF file, if you just email me at asdjones@gmail.com. A as in Apple, S as in Sam, D as in Dog, Jones @gmail.com. and just say you want the crib sheets for the YouTube stats from Dr. Zest or something like that. I'll understand. I'll get it to you. Okay. Good day. See you in a little bit on part 3. Work a problem together. Oh boy.